So good buddy. My name is Srikanti. I work with the Global Partnership based in Washington, D.C. And we monthly Numeracy Webinar series. And today we have Nadia Nosworthy from University of Western Ontario, or Western University in Ontario, Canada. And she's going to be talking about a 2-minute assessment that she uses at the early grades. It's actually part of her PhD dissertation. And she's going to be talking about how to basically the relationship between arithmetic achievement and magnitude in primary school. And she's going to be presenting details from Cambodia. So without further ado, I'm going to hand it over. And as you do the presentation, if you have any questions, please do type box and I'll convey them to Nadia at the end. Thank you so much. So Nadia, over to you.
Okay, good morning. Can you hear me?
Yes, I can hear you.
Okay, can everybody else hear me too?
Yes, we're good. Thank you.
Perfect. Well, hello everyone. I'm so glad you were able to join for today's session. So I'd like to present to you, as Deepa said, some research that I've been doing in relation to my dissertation. It's actually an assessment tool that I've been developing with my advisor, and we've been able to test it here in Canada and also in Cambodia. So I'd just like to share with you some of the results that we found. But I'll just give you a short introduction and fact relating to the assessment itself and the items that we chose. So because research shows us that math is so important to a child's overall well-being and academic success, it is essential that we advance our approaches to assessing the foundational competencies of numeracy. And when I speak about foundational competencies, I'm speaking about skills that are very basic, yet they lay the foundation for more complex skills. So for example, we can look to phonemic awareness. Phonemic awareness is the insight that words are made up of phonemes, which are the smallest unit of sound. And good readers are able to hear, identify, and manipulate phonemes. And research also shows us that early phonemic awareness skills in children is a very strong predictor of their later reading abilities. So children who show good phonemic awareness are the children who become good readers. So just like phonemic awareness is a foundational competency in reading, magnitude comparison, research shows, is a foundational competency for math. And when I use the term magnitude, I'm speaking about the number of set. So there are ways of assessing phonemic awareness that are currently available in the classroom. So now I'd like to show you ways that we have of assessing magnitude comparison. So one way of assessing magnitude comparison, this foundational competency, is with the use of symbolic magnitude comparison tasks. So when I talk about the term symbolic, as you see here, we have two symbols representing the quantity 5 and the quantity 3. So what I'd ask the child is, which is larger, 5 or 3? Now the beauty of this task is that it's very simple and very basic, yet it reveals a child's their underlying mental representation of the number 5 and the number 3. And it shows how well they are mapping the symbol with the quantity that it represents. So in other words, if a child correctly says, then you know that this child is learning to make the connection between number symbols and the quantity that they represent. So this is an example of symbolic magnitude comparison. And we also have tasks of non-symbolic magnitude comparison. So here, you'd ask the individual, which color is represented by the most dots, yellow or blue? Or another way of doing a non-symbolic magnitude comparison, perhaps with younger children, is with items or paradigms such as this one, and you can ask them, who has more crayons, Big Bird or Grover? Okay, and they have to make these decisions without counting. Now, what's also interesting about non-symbolic magnitude comparison is that this ability to compare magnitudes can also be seen in infants and animals who don't have any language. So it just provides further evidence of the importance of this foundational skill in developing higher order math skills. So what do we know? Well, right now, the research shows us that individual differences in the accuracy and reaction time measures of symbolic and non-symbolic magnitude comparison relates to children's arithmetic skills. So in other words, children who are highly accurate and are quick at these tasks where they compare number digits and where they compare dots or crayons, these children who are good at these tasks are also the children who perform well on standardized tests of arithmetic achievement. And one example of this work that came out of our where children were given the math fluency arithmetic subtest from the Woodcock-Johnson. So in this task, they are given 3 minutes to complete as many single-digit addition, subtraction, and multiplication arithmetic facts. And they were also given a symbolic magnitude comparison task. Okay, so here on the vertical axes, you see the math fluency. So these are the math fluency scores. And on the horizontal axes, we show the efficiency of symbolic magnitude comparison. So one thing I want you to note is that the smaller the value is the more efficient. So the faster and the more accurate the child was at doing this symbolic magnitude comparison task. And what the results showed is that children who did well on this symbolic task were also the children who scored highly on math fluency. This can also be seen in tasks of non-symbolic magnitude comparison. So once again, in this particular test, preschool children were given that same task that I showed you with Grover and Big Bird, who has more crayons, and they were also administered the TIMA, so the test of early mathematical abilities. So this test assesses basic arithmetic skills, some other early math abilities. And the children who did well on the TIMA were the children who performed well on the non-symbolic magnitude comparison. So here again on the vertical axes, you have the scores on the TIMA. And on the horizontal axes, you have the scores on how efficient they were at the non-symbolic task. So again, the children who did well on the non-symbolic were the children who did well on the TIMA. There are some challenges. So the current methods used to assess magnitude comparison usually rely on computerized software, making them resource intensive and expensive in some areas to test, and difficult to implement on a large scale. So the goal of my research then was to design a test which directly assesses both symbolic and non-symbolic magnitude processing in children. But I wanted this test to be low cost. I designed this test to be a paper and pencil test. We designed it to be quickly and easily administered and scored. We wanted something that could be used on a global scale. We included the non-symbolic to allow for testing across symbol systems, since we know that not all cultures use Arabic digits. And the non-symbolic also allows us to test very young children who may not yet have a fluent understanding of number symbols. So this is an example of the test. Right now it comes in booklet form. So we have 56 symbols and we have 56 non-symbolic. So again, the symbolic is the number symbols and the non-symbolic are the dots here in this case. We used magnitudes 1 to 9 for both the digits and the dots. And children had 1 minute to complete the 56 symbolic and then another minute to complete the non-symbolic. So for the task, they are simply instructed to cross out the larger of the two magnitudes in each pair. And what's important to note is that here, with the non-symbolic, they're told not to count, right? We want to access their approximate number system. So how fluent are they at approximation of numbers? Okay, that's what we're interested in here. And you'll notice that the dots vary in different sizes. And here is to make sure that in each box an equal amount of area is taken up by the dots. So that the children aren't relying on how much space, but they're solely relying on the numerosity or the number that's represented in each box. So these were my research questions. First question, is performance on this assessment related to standardized measures of arithmetic achievement? Just like what we see with the computerized, can I find these same results with this simple paper and pencil test? And secondly, if significantly related, can it explain significant variance over other factors such as age, working memory, reading skills, and IQ? So all of these other variables have been shown to relate to math. So I want to know, is my test able to explain the relationship between arithmetic achievement without other factors coming into play? So to answer these questions, we assessed 160 students here in Canada in grades 1 to 3. We administered some additional measures. So we administered my test. We also administered the Wilcox-Johnson. So 3 subtests from the Wilcox-Johnson test of achievement, math fluency subtest. So in this task, children, as I mentioned before, children are given 3 minutes to complete as many single-digit addition, subtraction, and multiplication facts as they can. They were given the calculation subtest, which is something very similar, except it's untimed. And they were given the reading fluency subtest, which assesses their reading fluency and comprehension. To assess intelligence, we administered the WASI. And to assess working memory, we administered the AMA, Automated Working Memory Assessment. And this is what we found. So we found a significant relationship between math fluency scores and magnitude comparison scores. So I'll just walk you through the graph again. So here we have the math fluency scores on the vertical axes, and here we have the magnitude comparison scores. And here I've collapsed between both the symbolic and the non-symbolic. So these are all the scores combined. So here we see that the children who did well on math fluency also did well on the magnitude comparison, and this relationship was significant. I also want to point out that symbolic comparison on its own correlated with math fluency, and non-symbolic on its own also correlated with math fluency. And then when we look at calculation, which was the untimed arithmetic, we also find a significant relationship between performance on the paper and pencil test and calculation. But then we want to know, is this finding math specific? So remember, as I was mentioning, other factors have been found to relate to math performance, such as IQ and working memory. So we wanted to know, did any of these factors confound with performance on the symbolic and non-symbolic comparison? So to answer this question, we completed a regression. And in this regression, we were predicting arithmetic skills using age, IQ, working memory, reading fluency, and then performance on the paper and pencil test as predicted. So the results demonstrated that scores on the magnitude comparison task accounted for unique variance in arithmetic scores. So in other words, the relationship was not confounded by these other factors. So if all children had the same IQ, had the same read, we'd still see variations in the scores on the working memory. Variations on the scores on my paper, and the relationship with calculation wasn't only dependent on their IQ and their working memory, their age or reading fluency. So what about reliability? So when you create an assessment, you want to know that the children who did well on the test at time 1, if you tested them again in time 2, they would still be the same children who did well on the test. So how stable is this assessment? So to investigate that, we looked at a sample of 39 first grade students, and we examined the correlation between time 1 and time 2 of testing. And this test demonstrated test-retest reliability of 0.72 between both periods of testing. So with this result, we see that there is stability in the test. So the children who did well the first time were also the children who did well on the second test. And the children who didn't perform so well on the first testing point were also the children who didn't perform so well on the second testing point. So it's showing stability. So just to summarize the findings from the Canadian data, results suggest that this assessment is related to standardized measures of arithmetic achievement. So again, just reiterating that the children who did well on the paper and pencil test did well on the arithmetic achievement. The children who didn't do so well on the paper and pencil test were also the children who didn't do, who scored, received lower scores on the arithmetic achievement. And performance on this test accounts for unique variance in arithmetic scores. So the next step then was, can these findings from Canadian classrooms be applied to other countries? So how generalizable are these findings? Can we take it outside of Canada? So to answer this question, we were able to take our test to Cambodia, and I'm in deep gratitude to Deepa for helping us organize all of it, helping to get the booklets ready and getting out to the schools and even doing the scoring. So thank you so much, Deepa. We had a sample of 985 students from 6 schools in Phnom Penh, Cambodia. We had students in grades 1 to 3. And for this, we were able to give each child the magnitude comparison task and the math fluency subtest in a group setting as follows. So one thing of note is that in Cambodia, the official language is Khmer. And in the school system there, the children are taught in Khmer in kindergarten and grade 1, and Khmer has its own number system. So given that fact, the children in grade 1 in our study were given the math fluency and the magnitude comparison task with the Khmer number symbols. And then by grade 2, the children start learning in Arabic digits. So here, we gave the children the math fluency and the magnitude comparison task using Arabic number symbols. So this is just an example then of what the test looked like in Khmer with the symbols. Of course, the dots remain the same. And then it just allowed us to see if we could find these same findings across number systems. And this is what we found. We found a significant relationship between magnitude comparison and math fluency. So just the same thing that we found in the Canadian sample, we found with the children in Cambodia. So again, this graph is showing math fluency on the vertical axes and performance on the magnitude comparison on the axes. This is again putting symbolic and non-symbolic performance together. We're seeing this correlation, we're seeing this relation. And once again, we see even for the symbolic only and the non-symbolic only with math. So this is just the cross-national similarities. Okay, so even across culture, and number symbols, and different teaching different teaching methods and all that, we still see that this is quite a foundational skill. It's there, and it's related to children's arithmetic achievement. So what this shows then is that this measure can be adapted and differences can be found across cultures. So just to recall, remember the children in grade 1, they only received this test in Khmer. And even so, we found this relationship between the symbolic comparison and the math fluency. So it doesn't matter if this test is given with Arabic digits, it can be given in Khmer digits, and I'm supposing that in any other number symbols, we'd still find this relationship between comparison and arithmetic, magnitude comparison and arithmetic. So then to conclude, this 2-minute assessment of foundational is related to measures of arithmetic in children, grades 1 to 3. It's flexible, so it can be used in a global to address differences in specific cultural instruction formats. And I want to assure you that children do really enjoy taking this test. It's very simple and it's fun because they're just told to go at it, go as they can, and they turn the pages and they do enjoy it. And along with being an assessment of foundational competencies, I think this test could be used just as a screener or early identification of children at risk. So by no means am I saying that this test is the test of all tests. I think that it's just showing there are other foundational competencies, of course, that need to be addressed and assessed. But magnitude comparison is one of those very important skills. And I think this test is very promising, a very promising way of assessing that important foundational competency. So I'd just like to acknowledge my supervisor, Daniel and Sarah, members in my lab and collaborators on this project. Once again, thank you to Deepa for helping us get the tests on the ground in Cambodia, and the Ministry of Education, Youth and Sport, allowing us to admit this test in their schools. So thank you very much.
Thank you so much, Nadia. That was a great. Any questions, please do type them into the chat box. And also thank you for all of the introductions. That's great. Thank you for introducing yourself. It looks like Shireen is typing in a question. Maybe while we're waiting for her question, maybe you can talk about, so when you do the dots, like when children have to select the larger number of dots, does that relate to any way measuring estimation skills?
Yeah, in a way, right? So we're testing their approximate, so their ability to combine and approximate objects in a set. Of course, there are other of looking at estimation as well. I don't know if people are familiar with the number line task, right? So where a child is given a number line, 0 at one end and 10 at the other. They're given the number 5, and they're saying, where would 5 go? Right? So way as well of estimation too. But this is tapping into kind of their estimation and estimation.
Okay, great. Thank you. Okay, so a couple of questions that are people are typing in.
Okay.
Yeah. Okay. Shireen says, "Hi Nadia, great presentation, thanks. 2 questions. First, determine the number of items Y56. And the second is Y56, yeah. And the second question is, how is time component able to do a quarter of the items correctly, efficient to gauge?"
So for the first question, Y56, well, this was based on number pairs that was in their public, and they were finding pairs, so we used in pairs. But what we chose those 56 numbers because it really represents, how can I say this accurately? There are certain distances between numbers that we wanted to constant across 1 to 9, the numbers 1 to 9 that we chose represents equal distances between the numbers. Does that make sense? We wanted a number of numbers that have a difference of 2 between them, a numerical difference of 3 or 4. So and when it comes to how important is the time, I think it's important because, as we know in literacy, time tests are a very important way of assessing in their ability to read words and the fluency. It's the same thing with numbers. So if a child isn't able to complete many of the tasks, right, many of the items, if they're only able to complete a few items, then we know that they're not efficient. So for example, on the number symbols, the digits, they don't get through many of those questions compared to the other peers. Compared to their peers, then we know they're not yet efficiently number symbols with dots, right? So that does story. So children who don't complete items.
Okay, great. Thanks, Nadia.
Are the children who don't
Michael,
do
who's
as well.
connecting from the question, he says, how do you score items they run out of time?
Right. Right. So those numbers, those items that they don't complete, we don't count those, right? So we're just looking at
We're getting a couple more questions.
Completed correctly.
Just a couple of seconds. Hold on. Okay. There's a little bit of a delay when they type in and when I see it. Okay. Juan, who's connecting from Mexico, says, "Hi Nadia, great project and congratulations."
Sure.
Okay. Thank you. Oh, and another question. He says, "Sorry, please divide by 56."
Thank you. Thank you. I divide by 56. So we
Shireen says, "Thanks, Nadia. A follow-up question on the time component. In context outside of North America, would you alter the time given that the 2-minute construct is something tied to American Canadian school standards?"
15 items, but they've only done 10 correctly, then they get a score of 10. Yeah, so that's definitely where piloting would have to come into play, for sure. Because if you're testing in Canada, then you're assuming that most of the children, they've received, some pretty good training in number. I've also been able to test this with kindergarten children, and I've taken
and Michael says, "Thank you for answering his question." And we have a question from Julie from Jump Math in Canada. She says, "Thank you, Nadia. How long after the Cambodian children learn Arabic numbers are they tested in that script?"
Children would be able to do. I think that's the flexibility of the test as well, that you can change the time to.
Yeah, so they, Cambodia grade 1 children learn. No, sorry, I didn't mean to talk over you. In Cambodia, grade 1 children learn the Khmer.
Deepa, maybe you can help me
learn in the Khmer script.
to remember the school year
their school year starts in October and then probably in June or July.
Do they test?
And then in second grade, they're introduced to the Arabic script. But towards the end of the grade 1, the teacher starts to introduce some Arabic script to the children. But in grade 2, they switch over completely to Arabic script. And then it's interesting because in grade 2, you see the children kind of interchangeably using the Khmer script and the Arabic script. But by grades 3, 4, and 5, they fully transition into the Arabic script. They don't go back to the Khmer script. Okay. Yes, yeah. So they were tested towards the end of the school year. So they had already been working for about a year in the Arabic script. Yeah, no, of course, that's okay. So you're getting a couple of other questions.
Yeah, so by the time they were tested with this, they've been working with Arabic digits for a few months. That's what I thought I remembered, but I just.
Okay, Julie says thank you, and Shireen says thank you for answering your questions as well, or our questions. Apologize for the pause. There's a little bit of a delay when people type in. Okay, Michael has a question. Has your literature research plus the empirical work given you any insight into the casual relationship between the skills you're tapping into, symbolic and non-symbolic, and math fluency?
Okay, you're welcome. Oh, no problem. Mhm. Yeah, that research is still being done. But one recent paper that just came out not long ago, I can actually put it up later if you want, looks at this tribe in the Amazon, the Munduruku, I think they're called, and they have a very limited numerical lexicon, right? So they just have basically one, two, three, and a lot. I may be exaggerating, but they don't have as complex a number system as we do. And they were able to look at um, individuals of this tribe who have received no schooling at all, and some of the children now who are receiving schooling. So they use this non-symbolic, not my tool, but a version of it, same tool, and they tested ability to compare these non-symbols. So if education doesn't play a role in non-symbolic, then you wouldn't expect to see any difference, right, in performance between the younger children and maybe and some of the older
So Michael asks that
individuals who
you
have
post a
received
reference to the Amazon
education
tribe. So
and
maybe what I'll
some
do
who
is
haven't
at the end,
received
at the end of the
education as
webinar,
well.
I'll
And what
put
you're
you
seeing
both
is
in touch.
that
I'll send Nadia's
those
email
who
out so
have
you can get
received
in touch with her and
education
she can
are better
send you the
at
article.
the non-symbolic
Shireen
symbol.
has another question.
So we
She
don't know
says,
exactly
how would you advise
what it
teachers
is,
whose
but we know
students
there is
struggle
some
on this
relationship
test?
between
What
education and
areas
being
within
able to use
foundation
these
math
types of
should they
tasks.
focus on with children who struggle with magnitude comparison?
Yeah, so what I like about this test is that it brings it a step back, you know. So in a lot of tests, the first thing to do is to give kids arithmetic, and we're taking it a step back. So if they're struggling with arithmetic, why are they struggling with arithmetic? And if they're able to do the non-symbolic version of the task, but not the symbolic version, then we know that they have not been able to match objects to the symbol that represents that amount of objects. So with teachers, I would advise that they do a lot of matching games, right? So here are three objects. Let's match which object goes with that. Or three taps. Let me touch you this amount of times. Show me which number symbol. Or it's like 6 beeps, right? So they're able to do this matching across modalities and different representations. So I
Shireen
think
says,
that's
great, thank
advice that I
you.
would give to teachers is really
Okay.
teach quantity,
So we're running out of
matching
time and I'm going to
symbols to
have to wrap the
non-symbols,
webinar
and
up,
then
but
understanding
it
as
looks like
well
there's a
that
couple of
5
more questions
is more
coming
than
in.
3,
Let me just turn my
5
video
is
on.
less than 7, and those types of activities I think are
We
very
can
foundational.
definitely continue this conversation on the community practice site, and I will put all of you in touch with Nadia and give you her email address so you can contact her directly. Okay, Julie has one more question. She says, have any of these tests been used with children who learn arithmetic on an abacus? Yeah, that would be okay. Michael says, great conversation. Thanks to you both. Thank you, Michael. Thank you very much for everybody who joined the presentation today, and thank you to Nadia for a great presentation and this
No,
very interesting research.
but that would
And
be
so we
a
look
really
forward to
interesting
continuing this
direction to take this for
conversation
sure.
on the community practice site, as well
But
as
unfortunately, we
if you have any
not been able
questions, you
to.
can definitely contact Nadia directly. I'll give your email. I'll give Nadia's email address rather to everybody, so you can contact her. And she's based in London, Ontario, in Canada, not the UK. See,